So we're going to start talking about polynomials, very basic stuff about it, just characteristics. Polynomials include just more than just lines and parabolas, but they also include cubics and quartics. That means fourth power and everything, and much higher powers. So just talking about really the end behavior to start here, and the leading coefficient, what happens with that. Just mainly basically characteristics. So what is a polynomial? You're probably wondering yourself, what is a polynomial? Well, it's continuous and has smooth, rounded turns. That's what the graph looks like. But in terms of like what an equation looks like, it's like has x to the something where it's a whole number. So every single time you see an x, it has a whole number as a power. No halves, no irrational stuff going on here. All right. It's always when you have a whole number as the power. Okay. The leading coefficient test. Whenever a graph polynomial function rises or falls, it can be determined by the function's degree and by the leading coefficient. Here's some different examples. So this one just goes up and up. And I'll kind of explain this. I have a different way to do this and how the notes are explaining it. I think it's very confusing. I'm just going to do it my way. My way or the highway, right? Well, let's just move on then. I'll get to that part when we get to it. Whether it goes up or down or not. What you really need to know, let me see what if they have a little thing here. Yeah, no, I'll just talk about it now. Okay, so pretty much I'm going to kind of scrap what they do and just talk about, when we talk about even, by the way, I'm not talking about the function as even, but the even power. So they say, hey, if it has an even power, and it's positive, positive is the leading coefficient. It looks something like this. That's an even power. There could be more things going on, but the end behavior, the left and the right are both going to infinity. The end behavior is what I care about. If it's an even power and negative, looks like this. Again, there could be a lot more twists and turns along the way, but each end behavior is negative. The left end and the right end are both going to negative infinity. If I have an odd power and I'm positive, looks like that. Again, lots more twists and turns along the way. But in this case, the end behavior to the right is positive. And that's what you usually talk about end behavior. So I usually care about where it ends. That's what's easier. So if it's a positive coefficient, the end behavior to the right is always positive. And if it's, in this case, an odd power with a negative coefficient, the end behavior is going to be, you all said it, negative. Or you thought it at least. So these are the three kinds. So as we go through here, where it says like up, up, down, up, whatever, so let's go ahead and go through this and use the little notes I just made you. So this first one. This one is even powered or odd powered? It's even. Is it positive or negative? It's positive. This first one right here, it goes up and up. You see? You just said that right there. So even power, positive, it goes up, up. This one is odd and negative. Well, odd and negative is like this, so it goes up to down. Does this make sense at all? Okay. I mean, if this is not making sense, you gotta tell me. I mean, I talk about I've used different lingo before. I'm just trying to follow the notes here. So here, let's go to this one right here. This 97 thing, okay? This is even and negative, so it's going. Even and negative is up here in my little chart. It's going down, down. So the end behavior to the left and the right are both negative infinity. That's a technical term. All right. Are we good? Okay. So when n is odd, and I really just did this. I'm going to give you more examples though. So when n is odd and it has a positive coefficient, let's come up with some examples. What's a polynomial that's odd and has a positive coefficient? X cubed. So what does that look like? And then when it has a negative coefficient, what's an example of that one? Negative x cubed, which is really just the reverse. So these would be, this first one's then down, then up, and this one would be up, then down. And I'm just talking about just the end behaviors. And then when n is even, let's say I have a positive coefficient. I just noticed I spelled coefficient wrong up here. Oh well, it'll be an Easter egg for the video. What's an example of a function that's even powered positive coefficient? X squared. Just do that one. I've already drew this, but let's put the words. This one is an up and up. So with a negative coefficient, that would be y equals negative x squared. So this one is down and down. Alright. Just describe the left hand and the right hand behavior of the graph. So for the first one, I want you to think about it on your own. You have four options. It's either up, up, down, down, up, down, down, up. Those are your four options. So number one, look at it, think about it. Let's see here. Calling someone random here. Zoe, number one. How would you describe the end behavior? You said down, up. And that is correct. It's odd powered. Odd means it's going to have opposite end behaviors, by the way. And then it's positive. And I always care about the right hand side. So the right hand side means it's positive. So it's down, up. Alright, look at the next one. We'll call another random person. Probably a male. Gender equality. We had Daniela go on her phone the second I said that. I'm going to call him a male. Daniela says, yes! I'm on my phone now. Yeah, I'm gonna go back on that. Daniela! What was number two? Down, down. How'd you get down, down? Even, negative, boom, we got it. Okay, let's talk about degrees now. So we can predict the end behavior polynomial, but let's take a closer look at the rest of the graph. So for a polynomial function with degree n, that just means it's the highest degree. Always with the highest degree, that's what we care about. There's two things we can talk about this. So the function has at most n zeros. What does that mean? Well, if I have this function right here, y equals x to the third plus x squared plus x plus 1. What degree is this example I just wrote down? It's 3. So at most, how many zeros does it have? It has at most 3 zeros. And the graph has at most n minus 1 turning points. Maybe I wrap that up in parentheses. These are also called relative maximums and minimums. This is called really extrema. You don't need to really know that right now, but that's a calculus term. So when you get the calculus and I say the word extremely, I'll go, oh yeah, I remember that. Totally said that in August of last year. I remember that. Said no one. Okay, so in this example, how many turns is this one going to have? It's going to have 2 turns. Alright, at most. It might only turn one time. Well, this one I know it turns all the entire time. But it has at most those many turns. So this one has 3 zeros at most, and this one has 2 turns at most. Okay? So what is a zero? There's like so many different words you can use for a zero. A zero is a root, which is an x-intercept. They're all the same thing. So anytime we talk about a zero or a root or an x-intercept, I'm trying to think if there's anything else, any other words that are involved right there. Probably not. Those are all the same thing, just whatever mood your teacher's in. That's what they're going to say. So how do you find zeros? Well, you set the function equal to 0. That's how you find zeros. Got it? Graphically, you just see how many times it crosses the x-intercept, or x-axis. And those are x-intercepts. Alright? So, let's go ahead and find all the zeros of this one. Which means that we better be able to factor it, because we don't know how to do anything else. So we have to factor this. So look at this first one right here. And find all the zeros. Which means I'm going to set this equal to 0. Can we see this or no? We're good? Zaid, can we see this back there? Okay. So the best way to do this is just to factor. So how does this factor? You can take out a -2 and an x squared is the highest one we can take out. Which leaves us with x squared minus 1. Can we factor this further? Let's practice our factoring. Yeah. How do we factor it further? X plus 1, x minus 1. So we set all of these equal to 0 now. So what are all my zeros? 0. 1. Plus minus 1, we cool with that? Those are my little, they're called braces. That wasn't a very good brace. That was an even worse brace. There was a slower brace. It's better. You don't need to put your answers in braces, but I like to, because I like to be right. So these are all the zeros. Actually, are there any repeating zeros here? Because shouldn't this have at most 4 zeros? Didn't we agree that? There should be at most 4 zeros. But how many zeros do I have?
3.
One of them is repeating. Which one's repeating? The 0. How do you know the 0 is repeating? Because it's to the second power. I have 2 zeros that are repeating. And we'll talk about what the heck that means in a little bit. It means something. It's important. Okay, find all the real zeros of this guy right here. So how many answers can I have up to? 3. How do I factor this? What's the first thing I do other than set it equal to 0? There's a GCF of an x. X squared minus 12x plus 36. Can I factor further? Yes, how do I factor further? X minus 6, x minus 6. So I set these equal to 0, so I set x equal to 0, and I set x minus 6 equal to 0. I don't need to do it twice, do I? No. So I'm going to have a repeating answer, right? What's my repeating 0? 6. I'm going to have 2 answers here. 0 and 6. They might even say like 6 with a multiplicity of 2. Just telling you what it could be written as. So if you see like an answer choice, you're going through like multiple choice. What are the zeros? They're like, oh, it's 0 and 6, but 6 has a multiplicity of 2. That means you're at a fancy party. Are we good so far? How to find zeros? All right, sketching. So we can actually sketch those other guys. So a couple things I do want to talk about real quick before we sketch are some of the behaviors of what happens when we have one, like a zero that repeats one time versus a zero that repeats two times versus a zero that repeats three times. We just get up to that. We do up to 3 zeros repeating in this class. So if I have a, what we're going to call it, x to the first. This is 1 0 repeating, which is not repeating. So this is just 1 0. We call this a cut. Okay, it looks like this. I'm gonna use the terminology cut because it's gonna cut through the x-intercept. So if we have just 1 0, it cuts through the x-intercept. If I have an x squared, how many zeros is this? This is 2 zeros at that x-intercept. Looks like this, like a parabola. It's not always up, it could be down. I'm going to say this is a bounce, because does it look like it's going to bounce off of something? Yes, it's going to bounce off the x-intercept. And then x to the third, how many zeros is that? This is 3 zeros. Looks like this. On the notes here, they call it a twist. I'm not going to call it that. This is going to be a flatten. See how it flattens out at the x-intercepts? That's the terminology we use in HP, yo. Highland Park. That's what I taught over there. That's what I called it. It's a flatten. It flattens at the x-intercept. So this is good for 3s, and this is good for 5s and 7s. Anything that's odd, it flattens. 3s, 5s, 7s, 9s, 11s, it flattens. You know what? If you have your preferences, you might like twists. What the heck does that even mean, twist? Like, there's so many different kinds of twists. Like, this is a twist. Like, yeah, I twisted. That's a twist. Alright, what's the difference between a squiggly and a twist? Nothing. Yeah, no one says that, by the way, just me. Yeah, Zoe. Yes, if it's an even, it's all be a bounce. So, yeah, so 2s, 4s, 6s. Good call there. Alright, so let's go ahead and sketch this graph. So, let's find the zeros first. So, 2x to the third minus 6x squared equals 0. Let's find the zeros. So, how do I factor this? Take out a 2x squared, which is going to turn into x minus 3 equals 0. So, I'm going to have x equal what and what? 0 and 3. What happens at 0? It's going to bounce. What's going to happen at 3? It's going to cut. So here we go. I'm going to plot that 0 right there. I'm going to write a B under it because I have a terrible memory. I don't know. I forget. So B means bounce. And then over at 3, I'm going to make 3 hash marks. So 1, 2, 3. And that's going to be I'm going to use C for cut. Okay, so all we need to know here is, now what kind of function is this? Is this an even powered or an odd powered? This is odd. And this is positive or negative? This is positive. So is this going to be up, up, down, down? What is it? Down, up. All you need to know really is that positive means it's up on the right-hand side. So you can sketch it from other way. I like sketching it from the right-hand side because I know it needs to be positive, right? So I need to start up there. So I'm going to start sketching this, and when I get to the first one, I'm just going to go right through it. Yeah, I went right through that guy. Oh, no! That's not a bad thing. That's what it wants. And then we're going to turn that train back around, and then we're going to bounce off of this guy. And kablamo, we graphed it. That was so fun. Oh my gosh, let's do that again. Okay, number 2. What does this have a GCF on? This one's a little bit on the tougher side. So I set this equal to 0. You said there's an x cubed. Is there a number in front of it or no? Just x cubed. You want to what? You want to do negative? I agree. I think it's easier if that leading number in that parentheses is a positive. So let's take out a negative x cubed. So it becomes 4x squared minus 12x plus 9. How does this factor this parentheses? I really hope it does. 2, 2, 3, 3. 2x, 2x, 3, 3. Minuses. Does that work? Okay. So the final product would look like this, by the way. The reason I write like that, because it's more obvious to me. Hey, we're going to bounce here. Hey, we're going to twist here. So, what are my zeros? X equals, and that's going to be a... No, it's a flatten. Or you say twist, I don't really care. I don't want to change who you are. If you're a twist kind of person. Which means I don't want you to change me either. Alright, and the next x value is going to be... Add 3 divided by 2, 3 halves. And that's going to be a bounce. So here at 0, I have a flatten. Oh boy. Notes are over. I broke my pencil. Out. Oh, I have another one. Very, very dull tip, though. I don't know how long it's going to last. And then at 3 halves, I have right here. That's going to be my bounce. Now, what degree is this one? Odd, and it is negative. So my end behavior is going to start down. So it's up, down. When I say start, it's because I always start from the right. I'm a grapher of the right to the left. That's how I was brought up. That's how my parents raised me. So I'm going to do it. Okay, so I'm going to start down here. Here I am. Here we go. I'm going to start down. I'm going to reach that first x-intercept, but I'm not going to go through it. Can't go over it. Can't go under it. I got to go through it. It's a book I read to my son, so... Going on a bear hunt, anybody? Anybody read that? That's a solid book. If you have not, pick it up at your local bookstore. It's a 3-minute read. I have a 4-year-old. The books I read aren't long. If they are long, I'd start making up the story. He's got a book, Dumbo. It's like 30 pages, and there's like a paragraph on each page. I go through that thing so fast. And Dumbo loses his mother, and then he goes into the circus, and people make fun of him, and then the tent falls down. After the tent falls down, they dress him up in clown gear because they don't trust him anymore, and then he finds a little friend. I forgot his friend's name. I actually have to read the book to find out what his friend's name is. A little rat. Anybody familiar with Dumbo? Yeah, no. So this is the story of Dumbo. I think it's Timmy. I think his rat's friend's name is like Timmy or Timothy or something like that. And then Timothy's like, Dumbo, you can fly because your ears are huge. So then the next time that they go in the tent, Dumbo, who is from like he's in a circus, by the way. That's probably important. So he's, we're like, tent. What's a tent? What? He's at the circus. So he's at like the top of a house in a circus, and then like the house he's on is on fire. It's supposed to be like a joke. They're supposed to like spray water at him. He says no, and he starts flying and with his ears flapping. And it becomes a beautiful story of, oh my gosh, that Dumbo can fly, and everyone lives happily ever after. Except his mom is still locked up in a jail, and they don't ever mention her ever again. I skipped that part. Like, and everyone lives happily ever after, and I'm like, I turn the last page. Oh, the mother gets out of jail. It's lovely. Now go to sleep, kid. That's how that works. Oh, I'm still in the middle of a problem here. Okay, so we bounce, and then we come back up, and we have to twist or flatten. That's why I like to say flatten, is because we kind of have like a flatter x-intercept right there. And then we come through. And then, yeah, that's what it looks like. All right, the last one. You want to try the last one on your own? No. Did you just say no? There's no one behind you. You're the tallest one. Hey, this is grouping, by the way. That's a little bit of a hint there. So give 3 a try on your own. It is grouping, so give it a good old try. All right, match it up with me. I got a -2, I got a 2, and I got a -3. Why did I get a -3? What did I do wrong? Nothing? Yeah, this is correct. On my notes, you have something different. Why do I have something different? Are they calling my notes key wrong? Yeah, they totally are wrong. This is the worst key ever. I don't want that. It's terrible. Okay, so all of these are cuts. They all cut. Okay, what about my behavior? This is an odd or an even? Odd what? Odd negative, so the right-hand side's down. Left-hand side is up. So I'm going to have -2, that's a cut. I'm going to have 2, that's a cut. I'm going to have -3, that's a cut. So I'm going to go through all of these. Bam, bam. Make sure you turn that back around soon enough so you can get that. This is a +3 right here, right? So you solve for it, you're going to get a -3. Now, sometimes I've seen people sketch these, and they do, like, totally crazy things. Like, they make up stuff. I've seen people go, like, it's the same example, where you have these zeros right here, the same example. They'll do this. They'll go like that, and they're like, oh, yeah, there too. Yeah, yeah. They make up their own stuff. Don't make your own stuff up. follow your zeros. Follow your heart. Follow your zeros. Okay, hey, let's do a table, because you have a table in front of you. I hand this out. You have a table? Yeah. Oh, I need those notes back. Can you get them from me there? I mean, I'm stuck. This cord right here puts me in jail. It's like Dumbo's mother. Can't go anywhere. Alright, so it has the first box filled out for us as we go through this. I don't even know if we need to do all of these. I don't think we really do. But let's go through a couple of them. It says crosses, wiggles, and tangent. I used 0 of those words. Wiggles are your twists, right? It sounds ridiculous to you. That's how your twist sounds to me. So we have cuts. We have flattens or twists. So we'll just say flattens. And tangent means bounce. None of these are mathematically technical terms, so that's why we can just say whatever we want. So the first one right there, you can kind of see how it's already, everything is already factored for us in that nice little form right there. So you can kind of see that we have x values of, all of these x values mean -2, 1, and 3. If you notice through all these examples, they're all going to be the same. They all have 1, 3s, and -2s. So in this case, the -2, it flattens or it wiggles or whatever. I don't know what that means, wiggles. And this 3-1, that's bounces, and the 1 just is it cuts. You can kind of see how it goes through there. All right, so let's go ahead and start. Let's just do number 2. Maybe do a couple of these, and then when we get bored of it, we'll be done. Isn't that how school should work? I'm bored. I'm done. You'd never leave my class then, right? Okay, so at -2, for number 2, what does it do at -2? Very good, class. It cuts. So this is going to be cuts. What does it do at 1? It bounces. I see what you're doing. I see, because it's more pleasing to your brain that way. However you want to, I'm not grading this chart. This chart's for you, so do what you want. I'm just following because they have the x's up here. And what does it do at x equals 3? It cuts. Let's skip the direction real quick. Let's go to the highest degree. To find the highest degree, you add all of the degrees up. If it doesn't have a degree, it's a 1. So let's add all of our degrees up. I have a 2 plus 1 plus 1. So 4. Okay? So highest degree is a 4. I'm not writing how they did it. They're stupid up here. Oh, they did that. Not a fan of it. So the highest degree is a 4. How do I know that? I have to add all of my powers up. If it doesn't have a power, it's an imaginary 1. So 2 plus 1 plus 1 is 4. So that's going to be an even. Is this positive or negative? It's positive. So it's going to go up, up. So you'll do a little bit of a sketchy poo here. So at -2, I cut. At 1, I bounce. And at 3, I cut. I'm coming from the top side, adding at the top side. So it looks like this. Alright, we good? Yours wrong. Oh no. What happened? Let's look at the next one. Number 3. I'm just going to stop at number 3 because I'm just wasting your time after this. Do you agree? I'm going to be wasting your time. I agree. Okay. I'll just do 3. I agree, your class is a waste of time. Okay, so at -2, what does this one do? This one cuts. Let's do C. Getting even lazier. What does it do at 1? Whatever you want. Flatten, twist. Here, I'll put like a TF, like a true false. Whatever one you want. Has anybody actually ever done that in their life? I remember when I was like growing up, like the teachers were like, "No, don't put a T and an F at the same time. Mark it wrong." I've never seen it as a teacher. Do you students do that? You've done it once? Please tell me you were like 5 years old when you did that. Oh, last year. Did you get away with it? Okay. All right. Has anyone gotten away with it? Yes. Yeah. All right. We're on camera. Don't admit it. Oh, 8th grade doesn't matter? Okay, I see how it is. All right, and what is it doing at 3? Very good, class. It bounces. That was a brilliant answer. What's my highest degree? 6. And it's positive, so it's going to be up and up. So it looks like this. Ooh. Is that better or worse than before? Worse. Alright, if any of you upset me, this is what happens. You know what? Stop talking. I'm going to do this. That's your punishment for the rest of the year. Is the yellow. Alright, to the nurse because I have a headache from all the switching. Alright, we good? That's all I really care.